Good morning, students. How are you? I am Manoj sir from AP. Today I am going to teach real numbers. Okay. First I will tell today which points I will discuss. First point is learning objective. Second point is fundamental theorem of arithmetic. Third point HCF and LCM. And fourth point relationship between HCF and LCM. So these 4 points I will discuss today. Okay. Now learning objective. That means why we will learn this topic. Students, mainly we will discuss in this chapter finding of HCF and LCM, fundamental theorem of arithmetic. Yes. So first, why we will learn HCF and HCF finding. Clear? Students, see here, one floor is covered by different designed square tiles. Yes. Now, if the dimension of the floor we know, suppose 300 centimeter by 330 centimeter. This is the dimension of the floor. Yes. Now, if we want to cover this floor by square tiles, then what will be the greatest length of the square tile, so that we can use minimum number of square tiles. To know the answer of this, we have to find out what the greatest number by which these two numbers are divisible. Yes. So that means greatest number by which these two numbers are divisible, that means the HCF of these two numbers. Is it clear? Say, what is the HCF? 300 and 330. 300 means by which number it is divisible. Still, we can write 300 means 30 into 10, that is 30 into 2 into 5. Yes. And 330, that is how much? 30 into 11. Yes or no? That means 30 into 11 and here 30 into 2 into 5. That we can write 30 into 10. So from these two, what is the greatest number we are seeing? 30. 30 is the greatest number by which these two numbers are divisible. So that means we have to know the HCF. And that is the importance of learning HCF. Is it clear? Now take one more example. In each box 13 oranges and here in each box 10 apples. So what is the minimum number of and equal number of apples and oranges required? Here, to know that, we have to find the LCM. LCM of 10 and 13. 10 and 13. That is 10 into 13. That means 130 apples and 130 oranges the fruit seller will buy, so that he can keep 10 apples in each box and 13 oranges in each box. And if you want to know total number of apple boxes, that is 130 divided by 10, that is 13 boxes apple, and 130 divided by 13, that means 10 boxes oranges. Is it clear? So main part is here to know the equal number of apples and oranges. To fulfill the condition, we want to know the LCM. Is clear? Now I'll discuss second point, fundamental theorem of arithmetic. First point completed. Now I'll discuss fundamental theorem of arithmetic. Fundamental theorem of arithmetic what? It states that every composite number can be expressed or factorized as a product of primes. This factorization is unique apart from the order in which the prime factors occur. Is it clear? What is the meaning of this? For example, say 30. If I consider this composite number, and if we find the prime factors of this, what are the prime factors? 2 into 3 into 5. Yes. So 30 is expressed as the product of these 3 prime factors. Now, what is the meaning of this? Unique. This factor is unique apart from the order in which the prime factors occur. That means if anyone write this 5 into 3 into 2, that is same as this. If other students write 2 into 3 into 5, that means same thing, 3 into 2 into 5 in this order, then it is also okay. That means the order is not a matter here. Is it clear? Now, 2 more theorems related to this. If n is natural number and p is any prime number, and we know p divides n square. If we know p divides n squared, then p divides n also. For example, suppose I am taking a natural number 8. Then what is the 8 square value? 8 square. So 8 square is 64. Now this number is divisible by which prime number? Which prime number? 2. Yes. So 2 divides 64. But according to this theorem, 2 divides 8 also. 2 divides 8 also. Yes. Now theorem 2, if a and b are any natural numbers and p is a prime number, and if p divides ab, then according to this theorem, p divides a, or p divides b, or p divides both a and b. This is theorem 2. So if I take one example, suppose 2 natural numbers I am considering, say 8 and 9. Yes. Now we have to find out a prime number p which divides ab. Yes. So what is the ab value? A here 8 and b here 9. So ab equals to 72. Yes. Now a prime number p which divides ab, that is 72. Which one? 2. We can consider 2 is a prime number which divides 72. We can consider 3 prime number which divides 72. So according to this theorem, 2 divides 8, but 2 does not divide 9. Yes. But if I consider 3, this prime number, then 3 divides 9 only, but 3 does not divide 8. Yes. This is the theorem. Clear? Now, I'll discuss one example sum. Express the following positive integer as the product of its prime factors. 6006 we have to express as the product of prime factors. So what is the first prime number? We'll take 2. 236003. Then next prime number 3. Yes. Next prime number, tell. Obviously not 5, 7. Yes. 14, 7 the 98, 2 21, 7 3 the 21. Now 11. 11 1, 11 3. So 6006 equals to 2 into 3 into 7 into 11 into 13. 6006 is expressed as the product of these prime numbers. Clear? Now example 2. Explain why this number is composite number. We have learned just now every composite number can be expressed as the product of prime factors. Yes. So to check or to know why this number is composite, first we will simplify it. 6 into 5 into 4 into 3 into 2 into 1 plus 5. So what is common factor? 5. So if I take 5 common, then what is left? 6 into 4 into 3 into 2 into 1 plus 1. That means 5 into, what is the result of this? 3 to the 6, 6 6 the 36. 36 into 4, 144. 144 plus 1, 145. So that means 5 into 5 into 29. That means the given number is expressed as the product of 3 primes. 5, 5, 29. 3 factors. It's clear? So that's why this number is composite. Therefore, given number is composite. Clear? Now I'll discuss the next point. HCF and LCM of numbers. This is third point. HCF of two numbers A and B, what? The product of the smallest power of each common prime factor in the numbers A and B. Common prime factor and smallest power. These two things are important. Common factor and smallest power we have to take. Clear? So first I'll explain it with one example. So if we solve this sum, then it will be clear how can we apply the method to find the HCF of two numbers. Yes. So 80, the first number, first we will express as the product of prime factors. It will be 2 to the power 4 into 5. Yes, how 2 to the power 4 came? 80, if you find the factors, 2, 40, then again 2, 20, again 2, 10, and 2, 5. Yes, that's why 2 to the power 4 into 5. Now 256, that is 2 to the power 8. So if you find the factors of 256, 12, 24, 18, 26, 24, 232, 216, 28, like this. So 1, 2, 4 and 2, 2. So how many 2? 3, 2, 5, 3, 8. So that means 2 to the power 8. Clear? Now I told we have to take the smallest power of each common prime factor. So what is the common prime factor? 2. And what is the least power? 4. So that means HCF of these two numbers will be 2 to the power 4. That is 16. Yes. Now come to LCM part. LCM of two numbers A and B, what? That is the product of greatest power of each prime factor, again each prime factor involved in the numbers A and B. But be careful here. Here common factors, but here not common factor of each prime factor involved in the numbers A and B. So this is the main part, important part. So again I'll explain it with one example. So already we got HCF, now we will find the LCM. So already these two numbers are expressed as the product of their prime factors. Now according to definition, LCM of these two numbers will be what? Common factors having the highest power, that means 2 to the power 8. But not only common factor, all the prime factors which are involved here, that means we have to take 5 also. Yes. So 2 to the power 8 into 5, that will be the LCM, and simplifying we are getting how much? 2 to the power 8 is 256. 256 into 5, that is 5, 6, the 30, 5, 5, 25 plus 3, 28, and 10 plus 2, 12. That means 1280 is the LCM value of these two numbers. I think this part is clear, students? Okay. So now come to example number 4. If two positive integers p and q are written as p equal to x square y square and q equal to x y to the power 4, where x and y are prime numbers, then find HCF of PQ, P and Q, and LCM of P and Q. Is it clear? So first I am writing P, what? X square into y square. Remember here x and y are prime numbers. It is mentioned in the question, x and y are prime numbers. Clear? And Q, x into y to the power 4. So HCF, just now we have learned HCF of two numbers P and Q will be what? Common prime factor having least power. So x is the common prime factor having least power is 1, and into, because we have to take the product of other, y is the common factor and having least power 2. So xy square is the HCF. Similarly, LCM of these two numbers, what we have learned just now, common and non-common, that means all the prime factors involved here, and we have to take the highest power. So x square you have to take and y to the power 4 we have to take. So x square y to the power 4 will be the LCM. I think this part is clear, students? Yes? Okay. Now example number 5. Find the largest positive integer that will divide 220, 390 and 741, leaving the remainder 3, 5 and 6 respectively. We have to find the largest positive integer. So largest means HCF. So we have to know the HCF value that will divide these three numbers, leaving the remainder 3, 5, 6. Since the numbers are leaving remainders, so obviously they are not exactly divisible. So first we have to know the numbers which will be divisible exactly. That means 220 minus 3. If you subtract the remainder, then we will get the numbers. So 217, 390 minus 5, 385 and 741 minus 6, 735. So these three numbers, what? Now the greatest number that will divide these three numbers exactly. Yes or no? That means basically you have to find the HCF of these three numbers. And for that we have to express each number as the product of primes. So what is the product of prime factors? 7 into 31. Yes. Next, 385. So find the prime factors of this number. So first give 5, 7, 35, 3, 5, 7, 35. Now 7 and 11. That means 5 into 7 into 11. Now 735, if we find the prime factors of this number, first give 5, 5, 1, 5, 4, that means 14, 5 the 70, 3, 35, 5, 7 the 35. Now we can give what? 3 we can give, 3, 4 the 12, 3, 9 the 27. Yes, now 7 and 7. That means 3 into 5 into 7 square. So HCF of these three numbers, 217, 385 and 735, is only 7 is the common factor and having the lowest power is 1. That means 7 is the HCF value, and this 7 will be the answer of this question. Clear? Now I'll discuss the next point, and that is the last point. I'll discuss now the next point, that is relationship between HCF and LCM. So this is our fourth point. Relationship between HCF and LCM. HCF of two numbers A and B into LCM of two numbers A and B equal to product of two numbers A, that is AB. And HCF of AB equal to AB upon LCM of AB. Similarly, LCM of two numbers equals to product of two numbers upon HCF of two numbers. Clear? So these three relations, very important relations. That means product of two numbers equals to product of their HCF and LCM. And if we know the two numbers, then we can find the HCF of two numbers. How? The product of two numbers dividing by LCM. Similarly, if we know two numbers and if we want to find LCM, then product of two numbers divide by HCF will get the LCM. Clear? Now, one example. The LCM and HCF of marks scored by Radha and Sama in a test are 1989 and 13 respectively. If Sama scored 221, what is Radha's score? Clear? So that means we know LCM value. LCM value given 1989. And we know HCF value 13 according to question. And we know Sama scored 221. Sama scored 221. So basically we know HCF and LCM value and one number. We have to find the other number. Yes. So just now we have learned one relation, HCF into LCM, that equal to product of two numbers. Say 221 into the other number which represents what? Radha's score. So if I consider that X, then HCF is 13, LCM is 1989, 221 into X. So therefore X equals to 13 into 1989 upon 221. Clear? Now cancellation. It is cancelled by 13. 13 1 and 9, 13 7 the 91. 17. Now if you divide by 17, 17 1, 228, 17 1, 11, 17, 7 the 108. So 117 is the value of X and that is Radha's score. Clear? Example number 6. Example number 7. The traffic lights at 3 different crossings change every 48 seconds, 72 seconds and 108 seconds respectively. If they change simultaneously at 8 am, after what time will they change again simultaneously? This is very important sums and it came in different exams many times. So please follow this question. So one thing remember here, if they change simultaneous, this word is very important. Simultaneous means here we have to find the LCM. This word indicates we have to find the LCM of these three numbers. So 48 expressed as the product of prime factors, 2 to the power 4 into 3. Now 72, that means how much? 2 2 cube into 3 square, 8 into 9, and then 108. That means how much? 36 into 3. 36 into 3 we can write, that means 12 into 3 into 3, that means 2 square into 3 cube. Finally 2 square into 3 cube. This is the product of prime factors. Clear? So what is the LCM value? What is the LCM value of these three numbers? Today we have learned what? To find the LCM, we have to take the prime factors involved in the numbers and highest power. So 2 to the power 4, 2 cube and 2 square. So 2 to the power 4 you have to take. Then 3, 3 squared and 3 cube. So 3 cube you have to take. That is 16 into 27. So 12, 16, 7, 112, 11 carry, 32 plus 11. That is 432. That means they will change after 432 seconds. 432 seconds after this time they will change. Clear? But if you want to convert into minute, that is dividing by 60, we are getting 7 minutes and 12 seconds. Clear? 7 minutes 12 seconds. So required time, therefore required time, what? Required time will be, since they started at 8 am, then after 8 am what will be the time? 7 minutes 12. That means 7 minutes and 12 seconds. And that is am. So at this time they will change again simultaneously. Clear? So this will be the answer of this question. I think this part is clear. Example number 8. Two numbers are in the ratio 11:5. If their HCF is 6, find the numbers. Since two numbers in the ratio 11:5, so we can consider numbers are 11x and 5x. Yes. And since HCF is 6, that means this x common factor should be 6. X value would be 6. So therefore numbers are 66 and 30. 11 into 6, 66, and 5 into 6, 30. So this will be the answer of this question. So students, I am ending my class here. If you have any more queries, you can contact me through my mail ID, that is manoj@TIGPS.in. Thank you students. If you have any more queries or if you have any doubts, you can contact me. Okay, have a nice day. Thank you students.